Okay, grade 10 sound waves, longitudinal waves from the November 2017 paper 1. Dolphins communicate through the emission and reception of sounds. A young dolphin is separated from its mother and starts whistling at a frequency of 130 kilohertz. The speed of sound in seawater is 1480 meters per second. So they are giving us the speed of sound, so that would be V, which is 1480, and this is in water. We know that in air, the speed of sound is generally around 340 or 343. And they're also giving us the frequency. They said that the frequency was 130 kilohertz. So now we need to do a conversion so that we can go to SI units, which is hertz, and the conversion from kilohertz to hertz would be times 10 to the 3 or times 1000. So I'm going to just say 130 times 10 to the 3 hertz, and then we have it in SI units. It's always a good idea to convert to SI units right at the beginning so that you don't forget. They ask us firstly to explain the term ultrasound, and we know that ultrasound is sound that has a frequency greater than the audible range. The audible range is the range in which humans can hear, and humans can hear up to about 30 kilohertz, a frequency of up to 30 kilohertz. So ultrasound would be sound that has a frequency greater than the audible range or greater than 30 kilohertz. And you could learn definitions from the exam guideline document so that you have them word for word. They now ask us to calculate wavelength of the young dolphin's whistle. And so the symbol for wavelength is lambda. So when I have all of this listed one below the other, I can see that I have the velocity v, I have the frequency, and I'm looking for wavelength lambda. And on the data sheet we have the equation v equals f lambda. So the speed v is 1480, the frequency is 130 times 10 to the 3, and that would allow me to solve for lambda. So if we put that into the calculator, we would get 0,011 meters. And that is the wavelength of the young dolphin's whistle. Another dolphin hears the distress call of the young dolphin 2 seconds later. How far apart are the two dolphins from each other? So let's draw a little sketch here. So we have the first dolphin and we have another dolphin, and they are a certain distance apart. We can say they are delta x distance apart. And the first dolphin sends out a sound wave, and the second dolphin hears the distress call 2 seconds later. So that means that from this first dolphin to the second dolphin, the sound takes 2 seconds to travel. So that is delta t. And we know that the speed at which the sound travels is 1480 meters per second in water. And they want us to find the distance between the two dolphins. So the equation we would use is speed is equal to distance over time. V is equal to delta x over delta t. So we have V, it is 1480. We want delta x, and delta t was 2 seconds. And that would give us an answer of 2960 meters. And that is how far apart the two dolphins are from each other. The speed of sound in air is 340. Briefly explain why the speed of sound in air is different to the speed of sound in seawater. Now we know that the speed of sound depends on the density of the medium. The greater the density, the greater the speed of sound. So we know that if we compare gases, liquids, and solids, air is a gas, and liquid would be seawater, or any water for that matter. So if we're comparing air to seawater, seawater has a greater density, and therefore it will have a greater speed of sound. And that is how we would answer this. Remember, density of the medium affects speed. And the other factor that affects the speed is the temperature. Describe how dolphins use echolocation to hunt their prey. So echolocation would be where the dolphin sends out a signal. So the dolphin would send out a signal, and this signal will reflect off the prey. So the signal would hit the prey, reflect off the prey, and the signal would then echo and reach the dolphin again. And then the dolphin would be able to calculate sort of to work out how far away the prey is. So the dolphin sends out a signal. The signal reflects off the prey and returns to the dolphin. So like how we would do a calculation on pen and paper, the dolphin is able to figure out very quickly without pen and paper, but it's able to figure out exactly where the prey is or approximately how far away the prey is. And that is how we would answer a question like this. And there are quite a number of animals which actually use echolocation to hunt their prey. I hope you found this video helpful. Please like if you did, subscribe so that you don't miss future videos, and share this video with your friends so that more learners can benefit from these lessons.